Auzubillahi minash shaitanir rajim. Bismillahir rahmanir rahim. Welcome back in the chemistry lecture of 11th science. Last time we have seen about the quantum mechanical theory. Now we will see the quantum number in order to understand the stability of the atom. With the help of quantum mechanics, we have understood about the stability of the atoms. So this is the last topic of the chapter, that is quantum theory, in which we have to study about the quantum numbers. So there are in all 4 quantum numbers. The first quantum number is principal quantum number. Before starting the quantum numbers, we will see the definition of quantum number. What is the definition of quantum numbers? So the quantum numbers is defined as the number which identify the state of electron, specify the energy associated with it, and its location around the nucleus. I repeat again, quantum number can be defined as the number which identify the state of an electron, specify the energy associated with it, and its location around the nucleus is said to be as a quantum number. These numbers are used to designate and distinguish electron in an atomic orbital. This quantum number is used to designate and distinguish electrons in an atomic orbital. In all, we have 4 quantum number. So let's see one by one. First one is principal quantum number. In principal quantum number, with the help of this principal quantum number, in the other word I can say that we can identify the electron in which shell the electron is present. With the help of principal quantum number, we can identify the shell of the electron present in which shell, that means in which orbit. Principal quantum number provides the information as the principal shell to which the electron belongs. And this theory has been given to us, that it was proposed by Niels Bohr, that n is a positive integer. We know very well this actually n is nothing but a number of orbits. Over here it is considered as number of orbit. Number of orbit cannot be 0, that is why the number over here it is not starting from 0. Principal quantum number determine the size of the orbit or shell, we can say, or a principal energy level. By this relationship we have seen previously. Yes, of course, it determines the energy of the orbit or shell or principal level. So actually it provides us 2 basic information. The first one is the principal shell to which the electron belongs, means in which shell the electron is situated, either in the first shell or second shell or third shell, by the number of n. N equal to 1 means first shell, that is first orbit. And the number of electron in any of the shell or orbit, I can say, is given by the formula 2n square. Remember carefully, this formula you have studied in 9th standard, 2n square. For first orbit, n equal to 1. So 2n square 2. L, second orbit, n equal to 2, 8. Third orbit 18. Fourth orbit 32. Fifth orbit 50. Sixth orbit, that is 2n square. So if I talk about the phi, so phi square 25 to the 50, that means in fifth orbit 50 electron, the maximum capacity of the electron is 50. Now actually angular momentum can be understood by the next quantum number, that is azimuthal quantum number. So from this we have understood about the principal quantum number. It is very small. From the principal quantum number, only 2 main important thing we can understand, that is the principal shell to which the electron belongs and the energy of the principal shell. Okay, so that was given by the formula. The next quantum number is azimuthal quantum number. Azimuthal quantum number is denoted by the small alphabet L. It was proposed by Sommerfeld. It was first actually denoted by the letter K, but now it is modified with small l. And in place of K, you just assume that it is n. So the value of L is equal to n minus 1. The value of L is equal to n minus 1. That means if the principal quantum number is 2, so the azimuthal value will be 1. One number will be less. And the k, that is k means principal number. The azimuthal quantum number depends on principal quantum number. So this k cannot be 0. In our textbook it is written n. So here it is printed as a k. So n cannot be 0, while azimuthal quantum number can be 0. Say for example k is equal to 1. So that is n is equal to 1. So n minus 1. 1 minus 1, 0. So L value can be 0. That means azimuthal quantum number starts from 0 and principal quantum number cannot be 0. It is also said to be as an orbital angular momentum quantum number, because from this quantum number we can give the formula for the angular momentum of an electron. And as it is a second quantum number, is also said to be as an secondary quantum number, and is also said to be as an subsidiary quantum number. L value depend on n, just previously I have told you. The value for L range from 0 to n minus 1. Just now I have explained about this, that if n equal to 1, that is L minus 1 is equal to 0. The value donates sub level of a main energy level. The value donates sub levels in the main energy level. Sub level means subshells in the shell. That means the number of subshell present in the principal shell. That means the number of subshell present in the principal shell. Subshell means what? Try to understand. Shell means orbit and subshell means orbital. That means if you want to understand about the concept, so try to understand with an example, that there is a building. In the building we have floors. So let us assume that in the ground floor there is no rooms. So in the first floor, if you assume that the principal quantum number 1, that is first orbit, first floor. In the first floor I have constructed that only one room. According to the quantum theory, as the number of orbit increases, the number of shell also increases. So in the first shell, that is first orbit, there will be one orbital. That means in the first floor there is only one room. Room is equal to subshell. Subshell means what? As in the floor there is a room, so we are living inside the room. As if suppose anybody will ask you that at what floor you are living, so you will say that we are living at first floor, second floor and so on. So if you are living at second floor, that means you are living in some of the room. So that room is said to be as a subshell and the floor is said to be as a shell. So if I will construct a building, I will construct in such a way that in respect with the quantum numbers, first floor only one room will be there, in second floor there will be two rooms, in the third floor there will be three rooms, and the fourth floor will have four rooms, in all total 4 rooms. And hence we don't require more rooms at the fifth floor. That is why till fourth floor you have to remember. First floor 1 room, second floor 2 rooms, third floor 3 rooms, fourth floor 4 rooms. So my rooms are subshell. The name of my subshells are S, P, D, F. So first floor K shell, that means K orbit, in which there will be one room, that is one subshell S. In the second floor there is 2 rooms, one is S and second is P. In the third floor, that is n equal to 3, there are 3 subshells, that is S, P and D. At the fourth floor, n equal to 4, there will be 4 rooms, that is 4 subshells, S, P, D and F. So this words says that the number of subshell present in the principal shell, means with the help of azimuthal quantum number we can identify the number of subshells, that means number of rooms present in the shells. L equal to 0, that means sub level, that is subshell. Try to understand subshell. Now as S, P, D, F are the subshell, in further G orbital, that is G subshell will also be discovered in the later level. Here I have written for your understanding level. S, P, D, F and G. Right now we are not using a G subshell, we are just familiar with SPDF. So for S subshell, here sub level is written, you understood as subshell. L value, that is azimuthal value, will be 0. Azimuthal value will 1, that is P subshell. If azimuthal value will be 2, D subshell. Azimuthal value will be 3, F subshell. If the subshell will be discovered as if I go on increasing my floors, remember carefully, the L value is not a floor, the floor value will be principal quantum number. So if I go on the 5th floor, there will be S, P, D, F, G, and at the 6th floor there will be S, P, D, F, G, and H, and hence it can go ahead. But as of now we require only 4 sub shell, that is SPDF. Now you can understand with the help of this marking as an subshells, 1 in the first floor, 1 in the second floor, 2, 3, and here 4. 1, 2, 3, 4. Why the line is over here? Because it is the energy is getting decreasing. That is why this level is at the bottom. See, 1s, 2s, 2p, 3s, 3p, 4s, 3d. That means the energy of 4s is less and the energy of 3d is more. So in the same way the electron will also feel, we will see later. Try to understand. This level has been came over here. It symbolizes that the energy level, this is actually the energy level. The lowest energy is with 1s, then 2s, then 2p, then 3s, then 3p, then in between there is a 4s, and then 3d. That means the energy of 3d is more than the 4s. 4p, 4d, 4f, and so on, we can go ahead. These are the spectroscopic terms and signify the full form. Try to understand what are the full forms of the SPDF. The full form of the SPDF is R sharp, S for sharp, P for principal, D for diffuse, F for fundamental, and G for generalize. If n equal to 4, the azimuthal quantum number will have values 0, 1, 2, 3, 4. 4 values. If n equal to 1, is there is only L equal to 0, that means 1 subshell. N equal to 2, 2 subshell. N equal to 4, there will be 4 subshells. N equal to 3, there will be 3 subshells. That means third floor, 3 rooms. The number of azimuthal value is equal to the number of principal value, L value. The number of L value is equal to the number of N value. N minus 1. It will be in the form of N minus 1. The energies of various subshell in the energy level is S will have low energy, P will have little bit more, D will have little bit more again, and so on. It tells about the shape of the orbital and also shows the shape of the orbitals. We have 4 rooms SPDF. As of now in our syllabus we have to study only 4 SPDF, out of which the shape of S, P, and D has been given in our textbook. Remember carefully the shape of the subshells. S will have spherical symmetric non-directional shape. P orbital will have dumbbell shape. Dumbbell shape means a lobe in the form of 8 will form. Double dumbbell means 2 8 will form in this way. F subshell, the shape of F subshell has not been given in our textbook, not been given in our textbook. The name of the shape is complex shape, as it is a quadra dumbbell shape or fold 4 dumbbell shape. It's quite complicated. Angular momentum. Now this azimuthal quantum number also provide the angular momentum of electron by the formula h upon 2 pi under root L plus 1. I repeat again, h upon 2 pi under root L plus 1. Small l. Capital L is the angular momentum of an electron. So I repeat again, capital L is equal to h upon 2 pi under root small l bracket small l plus 1. So in this way we can find the angular momentum of an electron. The same way formula has been given, h upon 2 pi under root ll plus 1. It is solved for the 1s, 2s and 3s. And the maximum number of electron in the subshell, that is SPDF. What is the maximum number of electron is given by 2 into 2l plus 1. 2 into 2l plus 1. L is a azimuthal quantum number. 2 into 2l plus 1. Okay. If you send this 2 inside, it will be 4l plus 2. So remember one of the formula, 2 into 2l plus 1. If L equal to 0, only 2 electron will come. Substitute the value of L equal to 0. 2 0 0 plus 1, that is 1. 1 2s are 2. L equal to 1, 2 into 2 1s are 2 and plus 1, that is 3, 3 2s are 6, 6 electron. So in all, that means p orbital will contain 6 electron maximum, and so on, as a d will contain 10 and f will contain 14, and g is not present with you. If in future, if you go ahead and study, you will be getting the maximum number of electron in the subshell of g will be as 18. Generalize. So this was the explanation about the azimuthal quantum number. Next time we will see magnetic quantum number and spin quantum number. Thank you.